Hey guys, welcome back. So in this video, we'll be discussing on the fourth problem of beams. So this problem is based on a uniformly varying load. A load of 12 Newton per meter is acting uniformly with a varying load from node I to node J. So this would be the working part actually. We'll be creating with the key points of 3000 mm distant, and the area of cross section would be this. So yeah, let's start the structural part in the ANSYS window. Hey guys, welcome back. So let's start the structural part of the fourth problem of beams. So let's start with going to the same procedure, selecting structural, and then going with beams to the elastic 3 and adding the real constants. So we'll have to add area, which is 100 into 100, and the IZZ, which is moment of inertia, 100 into 100 to the power 3 by 12, and the height would be 100 again. So let's click on OK and close it. Going to material properties, material models, selecting structural, going linear, elastic, isotropic, and the EX value for this would be e to 5 with the PRXY as a 0.3. Clicking on OK, close this window, and now we'll go to the modeling section by creating 3 points in active CS. So the initial point would be key point number 1 for the coordinates 0, 0, 0 along XYZ. Click on apply, and the second key point would be along 3000 mm along the y-axis, x-axis. Click on OK. Just connect these key points with straight line. We will add mesh right now. Meshing, go with the size controls directly. I'm going to manual size, lines. You can pick the line or click on all lines. Just keep the number of element division as 5. Click on OK. Then we'll do the meshing finally. Mesh, lines, and you can just pick all. So now the meshing part has been done. We'll just move on to assigning the loads. So in this particular problem, we'll be having two types of load. One is displacement and another pressure load. So the displacement will be applied on the first key point. We'll just go with the defined loads, apply and structural, then with displacement and on key points. So let's select the first key point, click on OK. So we'll have to be constraining the all degrees of freedom for this point, and displacement value would be 0. So clicking on OK, so the displacement load has been added. Next we'll move on with the pressure load. So the pressure load acting on the beam. So we'll be selecting the divisions which we done earlier in the meshing part. So selecting all 5 divisions and clicking on OK. So the pressure value at I is 12, and the pressure value at node J would be 0. So as we discussed in the initial clip, so in that we had a pressure value gradually decreasing over the right side of the beam. So at the initial I point, we'll be having the 12 Newton per meter, 12 Newton per mm pressure, and gradually it decreases to 0. So this is something called as a UVL, which is uniformly varying load. So let's click on OK. So you'll get a warning, you can just close it. So this is what we can observe. So next we can verify our solution by going to solution, solve and current ls. You can just click on OK. We'll get a note as solution is done. So next, once after we get this verification, we can move on with the general post processor, creating the element table, defining the table, and we'll be adding a BMD and SFD. So which is shear force diagram and bending moment diagram. We'll just add with the SFD I first by selecting by sequence num SMISC comma 2. So if you haven't watched the first video of beams, please watch that. I have explained briefly about adding these labels over there. So for FTJ, it's SMSC comma 8 and BMDI by sequence and SMSC comma 6 BMDJ. It's by sequence from again and SMSC comma 12. Clicking on OK. Make sure 2, 8, 6, 12 will respectively to the SFDI, J, DMDI and J. So just close it. Now we can proceed with plotting the results. Go to plot results, counter plot, in plot, counter plot, you can go to line element result. In line element result, make sure node I is assigned with SFDI and node J is assigned with SFDJ. Clicking on OK. So we'll get the shear force diagram displayed. So you can just download it or take a snapshot. The values might vary based on our given parameters which we applied on the preprocessor part, but the entire steps are similar. Follow the same steps. The value might vary, but the steps remain constant. So next we'll just get the bending moment diagram. So for that we'll connect the node I with BMDI and node J with BMDJ. So let's click on OK. So here we'll get the bending moment diagram displayed. Again, take a screenshot or anything if you want. And then we'll go to list results. In list results, we'll be listing the required results which is asked by the problem or the question. So here generally we'll be asked about reaction solution. So just click on that. So we'll be getting the reaction solution. You can just copy those values and this would be the end of this problem. We can even plot results and get the nodal solution over here. Do displacement vector sum, and also you can animate by going to style, size and shape, and make sure the display of element is on. Click on OK. Then when you come to again plot controls, animate, and click on deform shape. Make sure you click on deform plus and deform. Clicking on OK, we'll get the animated version of our current beam problem. So yeah, this completes the fourth problem on beams, and thank you for watching.